Hello everybody. I am Paolo Pieser, a systemician, an independent researcher, and some will say that I'm even a composer. That I'm not entirely sure. But what I'm sure about is that I bring some sounds into this world by creating algorithms that are then played either by humans or machines. Today I'm showing myself in this video because I would like to present to you GenExpr for musicians, a series of videos focusing on the GenExpr language found inside the Gen environment of Max Msp. GenExpr for musicians is inspired by Python for Everybody by Charles Severance, hence the tribute in the name, and it is for musicians who want to empower their music with some algorithms, for Max Msp users who want to open up to some of the possibilities offered by the Gen environment, and for musicians and composers who think might enjoy a text-based sample-to-sample coding environment. GenExpr for musicians is indeed a course on the GenExpr language, and also partially on the Gen environment, although under the lens of GenExpr. However, it is not a course on Max Msp, for which I suggest one of the many resources that one can find. There are many videos, there are some books, there are the tutorials prepared by Cycling74. There are even teachers ready to tailor their classes to the students' needs and learning styles. So, for this reason, I will assume a certain degree of prior knowledge of Max Msp, and I will not explain some of the things that we might encounter. So, if there are so many resources, why GenExpr for musicians? Well, for two reasons. The first is, yes, there are many videos about Max Msp, and there are some videos about the Gen environment. There are even some videos about the GenExpr. However, the authors of these videos are just using GenExpr and not explaining it. Thus, I decided to fill the gap. The second reason is that, as mentioned, there are many different learning styles. Some people learn better by interacting with somebody, some others learn better by reading a text, and some others learn better by watching videos. So while GenExpr for musicians is not exclusively for them, it is especially for them. Okay, so we gave a short introduction about GenExpr for musicians. Now let's give a short introduction on GenExpr by asking ourselves, and we can start by asking ourselves, what is GenExpr? GenExpr, and I read, is the textual internal language used in the Gen environment. It can be written inside the gen.codebox tilde object, as in the case of the text that I'm reading, or either inside the exp or codebox operators inside a gen or gen tilde patcher. So if we look inside the gen tilde patcher, indeed we see some GenExpr code, an expression to be precise. So the expression that says 1 plus 2 equals 3, and it is the case for both the operators exp and codebox. Okay, let's continue. GenExpr is used to state something that the compiler translates, error checks, and optimizes into low-level machine code computed on the CPU or the GPU, so that certain results or states are achieved. The code is read top to bottom in a sequence, and this sequence is repeated at every sample. Note that GenExpr does not bring advantages or disadvantages in the resources that the CPU or the GPU use for the computation over the visual object boxes. They are equivalent. So while I invite you to use GenExpr, of course, use the one that you feel the most comfortable with. Okay, so we saw what is GenExpr. Let's see why GenExpr, and consequentially, why the Gen environment. So if cables are a nightmare for you and a text-based approach makes things clearer in your mind, then GenExpr is for you. If you want to have more flexibility while writing your code, for instance by writing and using loop and conditional statements, then GenExpr is definitely for you. And finally, if you want to write your code without opening Max Msp, then GenExpr is for you. Now let's imagine you're traveling and you are on a train and the train is full of people, you can barely move, and you can't even imagine about opening your PC to write your code. Well, you can just use your phone with your preferred text editor and just write GenExpr code there, so that after that you can just copy paste it into the codebox operator or the gen codebox tilde object and check if it works and use it as you intended. Or you can even format your code in a specific way, save that specific file as a .genexp file that then will become a library, and call this library into another code that you are preparing, thus having access to all the code that you formatted in that specific way so that it became a function, which is, I think, pretty handy. So in this case, GenExp is for you. And when the Gen environment is for you, well, if performance is an issue, for instance, you have very heavy code or many instances of the same code, then the Gen environment is for you. Because Gen is at a lower level, thus it's closer to machine code than Max Msp, and thus it will use less resources of your PC. So the code will result in being lighter and faster. But not only, actually, there is also one characteristic of Gen that is very useful exactly for this scenario. So imagine that you're having a very long show, a long set, like 40 minutes, and you're not using every part of your patch and your code in all the 40 minutes. What do? Well, with the Gen environment, you can divide your code in different patches and then activate and deactivate them with a message either enable 1 or enable 0, so that you can always keep your CPU usage under control, which is pretty nice, I think. And finally, or better saying, one and a half final reason is that if you feel more comfortable with a sample-to-sample thinking, then the Gen environment is for you. It was my case. I was using Max Msp and I was sort of struggling in understanding how it was working and how to do my things for it. But once I switched to the Gen environment, something clicked in my mind and everything was so natural for me that I decided to stay and to continue to use. So if you are like me, then the Gen environment is for you. And the half of the reason which is connected to this one is that if you plan to design or prototype filters, then of course the Gen environment is for you because you want to work sample by sample. Okay, so we had a short introduction about GenExpr, and we saw that we use GenExpr to state something so that the compiler can translate it into low-level machine code and we can obtain something from our code. But how to, and pass me the term, speak to the compiler so that this actually happens? So how do we write our GenExpr code? Well, in programming languages, we give instructions to the compiler by making statements, thus by stating something about something else. This something else is called a variable, which is a named storage location in a computer's memory, in which data can be stored, retrieved, and modified, and whose state persists until a new read of the list of statements occurs. Then the variable must be stated again. Okay, so we are saying something about something else, which is called a variable, which is a space in the memory of the PC, and whose state persists only until the end of the list of statements, of the sequence of statements. But what does the last part mean? Well, it means that if we have at the end of a list of statements the statement A equals 4, so the state of A is 4, we cannot expect that at the start of the new read of the list of statements, we will have access to A, first of all, that variable, because we will have access to that variable when it will be declared again. Sorry, it will be stated again. But more than anything else, we won't have access to that state. So if we want something that carries over from sample to sample, we need to use the operator history, which will be part of the topic of one of the latest videos. Okay, so let's see what kind of statements we can make in GenExpr. The first is the assignment statement. So assign the state of that variable or that constant, where a constant is a fixed and a modifiable value, such as a number, to this variable. Or said in another way, state this variable as the state of that variable or as this constant. An example of this is x equals to 2. The second kind of statement that we can make is the assignment expression statement. So state this variable as this expression. An example is x equals 2 plus a. Then the third kind of statement that we can make in GenExpr is the conditional statement, which says that if this conditional expression that I prepared is true, then read the statements that you want to make. Otherwise, if it is false, don't read them. An example is if x equals to 1, so x equals to 1 is the conditional expression, then read the assignment expression statement here, which is x equals x plus 1. Finally, the last of the statements is the loop statement, which is a very special one in my opinion. Without getting too much into detail, there is an internal conditional expression to the statement, and as long as this conditional expression is true, the same statements are read in a loop within the same sample. So there's not one iteration for each sample. All the iterations are read inside within one sample as long as the conditional expression internal to the loop is true. So an example is for I stated as 0 and I less than 5, read x, state x equals to I. Then update I with an operation, in this case an incremental operator, and then check if it is still true, the conditional expression. If it is, reread the statements and so on, until the conditional expression is false. Okay, so we exhausted all the kind of statements which we know are set of instructions that we give to the compiler and that we know are written in GenExpr and that we can use GenExpr to write them. So it's intuitively possible to understand then what a program is, because a program is nothing else than a list of statements that return the state of certain variables chosen by the users, or that writes something into another location in the memory. As simple as that. So while we write GenExpr code, we write programs. Okay, so two final remarks about the statements and one warning. The first remark is that every statement must be concluded with a semicolon, otherwise it will not be considered a statement. And the second one is that multiple statements can be made in the same line of code by using commas. So for instance, variable 1, comma, variable 2 equals 0, 1 means states variable 1 equals is stated, or better saying 0 is the state of var1 and var2, and 1 is the state of var2. Sorry for the confusion. Now, one final warning. GenExpr does not support strings of letters as statements. Thus, the statement x equals hello world will produce an error on the console. Okay. So, let's go to this part. So, we can see a little bit of the code, some of the things that we can do with variables that are possible with variables. But first, let's start with a note about the names of the variables, because we cannot use everything we want. Variable names are case sensitive, so there is a difference between the variable name that is the same but has majuscule or minuscule letters in different positions. Not only variable names cannot have the same name as other gens operators, because those are reserved words. So for instance, plus equal, peek, poke, buffer, so on. And also variable names cannot start with numbers because those are constants. However, they can finish with numbers. So at least we can do something. All right, so let's look at this code that I prepared. And I wrote it in these many different ways just to show you that we can do this, that is possible, that it's a possibility for you. Just remember to write your code in the most clear way, and that is the thing, the idea that you should follow. Because especially after reading it after a while, you will not understand certain things, but if it is clear, you will be able to retrace what you were doing. Okay. So here we state that var equals in1, so we make this statement that var equals in1, and we make this statement that out1 should output the state of var. We know that in1 is 1 from here, thus we check if out1 is 1, and indeed it is 1, so it works. Then let's see how var2 is stated. It's stated as the value of int2, which is free. And we search for where var2 is output, and it is output from out free. And indeed, int2 is free, so out free is free, and indeed it is the case. So you know here the drill, var3 and var4 are stated as int3 and int4 as the value of int3 and int4. And indeed, int3 and int4 are receiving the value 4 and 5. And now we see that out4 and out5 are outputting var3 and var4. Thus we are expecting 4 and 5, which indeed is the case. And finally, one of the possible things that we can do with variables, which is we can update the state of a variable with an expression involving itself. So in this case, we have that updated variable is stated as var plus 1. So 1 plus 1. So we know that out2 outputs the value of var, and thus we know that we see that indeed out2 equals to true. Okay, so one final thing about variables is that we can update them in the same line of code. So we have that here that var another equals 3, and then we have that var extra, var another, and var extra 2 are stated as var another plus 1, thus 4, var extra plus 1, thus 5, and then var another plus 1, thus 6. So we also see that out1, out2, and out3 are var extra, var another, and var extra 2. So we are expecting that the state of each of these variables are being output. And apparently it is the case because 3 plus 1 is 4, 4 plus 1 is 5, and 5 plus 1 is 6. Okay, so for the video of today, this is it. I hope that everything was clear enough for you, but if it wasn't, please leave your doubts or together with your comments or feedbacks down below. I am glad to have you here for this first episode of GenExpr for musicians, and I hope to see you at the next one. Have a fantastic day, afternoon, or evening. Ciao.